All right, we have a good number of participants already, so I will start introducing the webinar. So, good morning, everyone. Welcome to this very exciting first webinar on the DestinE platform, specifically looking at the GeoAI and the implementation through the contractors from FlyPix AI. So, I'm Diego Domenici from Trust IT, one of the contractors of the DestinE Initiative website and communications, here with my colleague Claudia Donofrio. I'll be giving a very short introduction to this webinar before I pass it over to Barbara Scarda from Cerco and then our friends from FlyPix AI. So here's a quick overview of the agenda. Short welcome now. Barbara will then give an introduction to what the DestinE platform is and how it works. And then we will dive into the actual meat of the webinar, which is looking at GeoAI and how the service works and looking at 3 specific use cases, which will be showcased by the 3 engineers from FlyPix AI, who are Sergei Sukanov, Enrique Fernandez, and Jacob McWilliams. Please feel free to type any questions you have in the chat, which we will then try to go through during the Q&A session, and then we will have a short wrap-up. So before we dive into it, a short couple of housekeeping points. The webinar is being recorded, so be aware of that in accordance to the privacy policy of the website and of the web form which you've filled in to access the webinar. The recording and the slides will then be accessible from the event page once we publish them. There will be a link to where they will be uploaded either on YouTube or on the platform itself. And then feel free to introduce yourselves in the meanwhile and to ask questions, as I said, in the chat during the actual presentations, which we'll then go through later. And stick around for the end because there's an expression of interest and post-event, let's say, a review form, which will be shared with you during the final 5 minutes of the event, because we're quite interested in hearing your feedback and your interest in learning more and maybe having a say in how the DestinE platform will be moving forward. So that said, thank you all for being here. Enjoy the webinar, and I will now be passing the floor to Barbara Scarda from Cerco. Thank you.
Good morning, everyone. First of all, thanks to Diego for the introduction to the webinar, and many thanks to all of you for joining the first DestinE Platform webinar. My name is Barbara Scarda and I work for Cerco. We are under a contract with the European Space Agency to implement and operate the DestinE Platform together with an industrial consortium. Now, before handing over to the colleagues from FlyPix AI, I'll take just a few minutes to introduce the platform and walk you through the processes to access the available services. So I'll mention registration, access upgrade, the service registry, user support, and the public roadmap. So the DestinE platform is one of the 3 components of the Destination Earth initiative of the European Commission. It's an ecosystem of services designed to tackle global challenges through cutting-edge technologies and seamless access. Let's go quickly through the user journey on the platform, as each step is interconnected to ensure a smooth experience. So the first step is registration, and it's a standard process. I believe most of you are already registered users, so I will not get into details here. However, I just wanted to point out that it is important to fill in the user profiles field if at a later stage you wish to apply for upgraded access. You can do this during registration or later from your user profile. A few words about what upgraded access means. All registered users get basic access to a selected list of services available on the platform, including GeoAI. But if you want to access services that allow downloading of what's defined as DestinE primary and alter data, you need to apply for upgraded access. Here you find the definitions for clarity. DestinE primary data refers to datasets from the DestinE digital twins, whilst altered data means data derived from primary data that could be used to reconstruct the original primary data themselves. So if you wish to upgrade your access, you can request it from your user profile after logging in. There is a clear dedicated section for that. Moving on to the service registry, you can access it by clicking on services on the navigation menu. This is where you'll find all the services available on the platform. Right now, we have 23 services, and you can easily filter them by category. For example, here's a list of the main categories: visualization services, or development or processing environment services, or data analysis and modeling services like GeoAI. So how do we support users? There are several ways to get help. You can check out the support section on the navigation menu for reference. You'll find the frequently asked questions. They're really handy if you're looking for quick answers, or the services documentation, or you may wish to get in touch with us directly by the service desk using the contact us form. We also have a series of video tutorials for the services that will be published soon. They will also include a GeoAI step-by-step video tutorial. And finally, mention of the public roadmap, which you will also find under the support section. You will find here a list of upcoming features, recently released features, and most importantly, ideas for improvements suggested by the user community. This is part of our effort to stay transparent and make sure that the DestinE system evolves based on real user input. So that wraps it up in hopefully around 5 minutes. If you have any questions, feel free to ask or get in touch by the service desk if anything comes up later. Now I'll hand it over to Sergey, who's going to introduce you to GeoAI. Thank you.
Thank you, Barbara. Hello, everybody. My name is Sergey. I'm co-founder and CEO of FlyPix AI. And with me today, I have a senior machine learning engineer, Enrique Fernandez, and a data scientist, Jacob McWilliams. So today we are going to present you some practical insights on how to use the system. But first, I will show you just 2 slides to introduce GeoAI. Hopefully you can see it. So this is a just cover slide to see the main idea of the service. And this is practically the introduction. So it's a cloud service that works with satellite, drone, and aerial imagery, right? So it's raster files that are coming from above, image files. And what you can do with the service, you can create your own Earth observation use case where you're required to monitor something, to detect something, or to inspect some territory. What's unique about this is that it's extremely user-friendly. So you as an end user, you don't need to have any AI or geospatial knowledge. You can be just an expert in your field, forestry, agricultural field, or city municipality, for example. This is one of the segments. And why it's interesting, or why it's cool to use this service, is because it's very efficient. So it allows you to reduce your time in inspecting or monitoring some large areas, for example. And obviously, with respect to cost, it's also very interesting. So I will now make a quick walkthrough through the service. So how you get there is from the main page of the Destination Earth platform. You just click Go to Service, and then you log in and come to the GeoAI service. So what you see here in front of you is a dashboard that shows your last activities, what you have done, what processing was you were doing, some kind of storage details, how much data you store, what from this amount is dedicated to AI models, to your results, to your rasters, and so on. So first of all, let's go to projects. So here is practically your projects that are organized in a usual fashion. You can create a project by clicking here, this symbol plus, assign a name, quite simple. Then you have maps. This is practically the outcome that you create to share with your colleagues, with your friends, maybe with the community potentially. So this is the results or the outcome of your work. GeoRasters, this is the place where you can access all the rasters that you uploaded or got from the data market. Data market I will cover in a minute. AI models, this is a central part of the service. So these are all the models that you create, that you train. So these are models that are based on the data that you might bring to the platform, that you label and then create these models. What's interesting here is that you can click on every model and see its metrics, understand how good it is, what it was trained on, and so on. And the last point here is a community. So every person who is registered in GeoAI, this person can share the work with the community, with the whole GeoAI community, and this work comes here. So everybody can use it, can see what you are doing. Maybe you have some public work. Maybe you would like to share your results with everybody. Maybe you would like to get also feedback. So this is the page for this. Data market. So data market is used to get the data from the DestinE platform, and it's quite intuitive here. So what you see is the data that you already acquired through the platform. I have one file, Sentinel-2 RGB. It's very easy to use. You just navigate through the map, select the region that you are interested in, and click search. Obviously, there are some additional filters and parameters that you can use. You can apply the maximum cloud coverage. You can select the date, or you can select the data type that you want to have. And here on the left, you see practically the results of the search. So you can click on the image that you like. You see directly on the map, it highlights where this region exactly located, and then you click acquire, and then in some time, this image will appear here in your data tab. So that's more or less the intro that I would like to share with you. And now I would pass to Enrique to show you the first use case. Hopefully you will enjoy it. Thank you.
Thank you, Sergey. Welcome, everyone. Thank you for joining. I'm Enrique. I'm a machine learning engineer at FlyPix, and what I want to do is show you how to use GeoAI to solve one of your use cases. So let me share my screen. There you go. All right. So, all right, let's start with the first use case. This one would be forestry or agriculture. Specifically, we want to count palm trees. Now, why would you want to count palm trees? Well, there's a couple of reasons. This is actually a real use case that is quite prominent. One of the reasons might be that in some cases, farmers and in general in the agriculture industry, they might pay contractors to plant a certain amount of trees, and they want to, well, either verify that the contractor met the requirements for how many trees they say they would plant, so they can do a quick verification after the job is done. Or if you're on the contractor side, you might actually want to count after to then bill accordingly. There's another reason why you might want to count trees, and that's carbon credits. So farmers can apply for these carbon credits, and they serve as a means to compensate for CO2 emissions. And depending on the size of their terrain and the amount of biomass that is in that terrain, then they can get more or less carbon credits. Then what happens with these carbon credits is that governments or companies can purchase them to compensate for their CO2 emissions so that they can meet the CO2 emission rates that are prescribed by laws. So you're a small farmer, you want to submit your paperwork for this carbon credits, and you have a large terrain that you want to count the number of trees, but these trees might be tens of thousands. So it's not feasible to do this manually, or at least it would take a very long time. Now, we can fly a drone and over your terrain and take some pictures, and then you can use GeoAI to solve this quite quickly in a matter of minutes. So what I'm going to do is I'm going to show you how I would solve this use case using GeoAI if I was that farmer that just is interested in counting the number of palm trees in their terrain. So I'm going to go to GeoAI. This is what Sergey was showing. I am going to go to my projects. The first step would be to create that first project. You just click on the plus there. You can name it to something like palm tree counting or whatever you want to call it. And then it's as simple as just uploading your GeoTIFF. I would have it here. It's slightly large file. I'm not going to upload it right now, given that my internet connection is not the best right now, but you upload it here. It takes a little bit of time to upload. And after processing for a couple of minutes, you have your file available. I prepared it beforehand, so I have a couple of files here. It's the same one that I uploaded twice, but this is what you would see after uploading. So now that you have your file uploaded, you can inspect your file directly from the platform. So this is a large GeoTIFF that was made from drone images. It was stitched together, RGB, 3 channels. Now, as you can see, there's a very large amount of palm trees here. I definitely wouldn't want to count all these trees manually. It would take a very large amount of, very long time. But thankfully we have GeoAI, which can really help us because we can train a model, we can teach them to detect palm trees and count them very quickly. Now, how do we teach the model to count palm trees? Now, the first step is to show examples. We have to tell them what it is that we want to find. So we have to tell them what is a palm tree. The first thing I'm going to do is create a new vector layer, and I'm going to call it annotations. And here I'm going to put some manual annotations where I manually say this is a palm tree, this is what I want to find. So I can add some polygons. And the traditional way would be to basically draw a polygon around a palm tree like this. And like this, we're telling the model, hey, this is a palm tree, right? Now, for a model to start working appropriately, you might need 50, 100 examples. It depends a little bit on the class you want to find. If the class is very uniform, like these palm trees, you might get away with 20, 50. If it's a more, let's say, polymorphic class where the shapes and forms vary more, then you might need more examples. But yeah, annotating is boring. So thankfully we have AI, which is our feature here, to annotate more quickly. Here, what we can do is simply say, hey, this is a palm tree. And if we wait for a couple of seconds, it actually finds all similar objects to the one that we just showed. And I think it did a pretty good job. It's not perfect. It missed a couple, but we can try again. So what I'm going to do is I'm going to try again with this one, and it did a good job. So it filled this area quite well. And if you check, I'm going to enable and disable. It did a pretty good job of quickly, in a matter of 5 seconds, label 153 palm trees. Now, this would have taken manually probably half an hour or something like that, perhaps more. But with the AI, it's as easy as just showing one example, and it kind of infers what the object you want to find is. All right, so the next step would be to create a training region. So we have to tell the model, I want you to train on a region that is fully labeled. So I'm going to go here into training mode. And I'm going to create a region around an area that is fully annotated. Now, it's very important that when you create a region, it is fully annotated. So if there are trees around here that are not yet annotated, that would hinder the performance of the model, because we're basically telling it that this over here is not a palm tree. So you have to make sure that the regions you select for training are 100% labeled. Yeah, and so this region would be ready. Now, I suspect it could happen that by only using this training region, the model might think that we want to find all trees. So it also helps to show the model not only what you do want to find, but also what you don't want to find. What we don't want to find are these trees over here. So for example, I could create a training region here to say that I don't want to find these trees over here. But I do have to label all of these over here. So actually let me do that quickly with Copilot. Let's do that with the AI. It missed a couple and it has a couple of false positives, but we can fix that quickly. Let's just keep iterating until we have this region more or less labeled. And yeah, so this one's not, see, the Copilot thought that these were palm trees, but we actually don't want to find these. So what I'm going to do is delete these. Oops. Let me refresh. All right. All right, let's delete these because we don't want to find them. These are not palm trees. All right. Cool. So now we're ready. Maybe I have to refine this training region. Let me draw it again. So this is a region where we can train. And this is a very nice region because we're telling it, hey, these are all palm trees. These are all not palm trees. This is what I want the model to learn. We can also create fully negative regions. So I can just create a completely empty region here, basically saying nothing in here is a palm tree. And then specifically for this use case, I know that there's these baby trees that were planted recently, and we are not interested in finding these. So if you were interested in finding these, you would have to annotate these. If you're not, then you would not. So I'm going to create another region here and not annotate it. And perhaps there is one more palm tree region that I can create, something like that. And yeah, so now we have those two because we have to make sure that the regions are fully labeled, but we don't want to find these. All right, so we have these 4 training regions where we have annotated, we have shown examples of all of our palm trees. These 4 regions are here, and the next step would be to click continue. And I'm going to give a name to the model. This would be palm tree detector. And then you have to choose the type of the model. So we can choose either object detection or semantic segmentation for the type of the model. So object detection is better for individual objects, things that you would pinpoint as a single object, something like a car, a tree, a building, a specific, I don't know, a trash bin, a container, something like that. Semantic segmentation works best for areas. So if you're segmenting maybe grass, maybe water bodies like lakes or rivers, roads, in general, things that are not a single object, but more an area that spans, well, a larger area, for lack of a better word. So in this case, we want to find trees, so I would select object detection. In the next use case, my colleague Jacob will be showing semantic segmentation. So here we have a training data overview. So I'm training on this file. It has 4 regions, a total of 6.24 megapixels, and this would be the credit cost. 1 credit for these small regions. GeoAI users get 25. So I click start training, and now this starts processing. And after waiting for a bit for the model to train, which takes a few minutes, we would see the model. We would see the model available in our project. Now, since this takes a couple of minutes, maybe 10 to 14 minutes, it's going to take. I prepared a model for you. Once the model is available, we can come back to regular workspace mode, and we can click on this icon here, the little robot, and this is our model page, which we can show. And this is the one that I trained before. This is the one that is training right now that I just put as training, and it will be ready once it's done training. Now, I can just apply the one that I trained before. And again, after a few minutes, this is quite a large raster with high resolution, so it takes about 16 minutes. But after 16 minutes, we would have all of the trees counted here. Thankfully, that's machine time. It's not our time, so we can just go get a coffee. And when we come back, all of the trees will be detected. So yeah, let me show you that model page. So this is the palm tree detector that I showed before. that I trained before, sorry. Palm tree detector, so we can see the performance. We have a bunch of different metrics, which with some explanations. They're a little bit technical, but they have a low value interpretation, and we can, after we trained a model, we can know whether the model did well or it did not so well. In this case, we have an 87.2 MAP50, which is quite good. It's not perfect, but it's quite good. So let me go back to that project to the complete, and this is where I already applied the model, and this is what the final output would look like. So we would see every single tree with the bounding box shown, and the total count would be 16,358. Now it might not be absolutely perfect. There might be some false positives, false negatives. Maybe that's a palm tree, maybe it's not. But it's a very, very good estimation, much better than one we can do with just calculating the area, the hectares of our terrain, and the average area of a tree. It's that's not going to give us as good of an estimation as this. We have an attribute table where we can see all of the palm trees. I can sort them by confidence, so I can see what the model was most confident about. In this case, it was this tree. The second most confident is this one. You can click, for example, here. This one is a little bit less confident, is 60%. I guess it's because it found a palm tree that wasn't within the pack, within the terrain. So then, I mean, you can either delete this. If it doesn't suit your use case, or you can keep it. I'm just going to keep it there because it does appear to be a palm tree. But that's pretty much it. That's how manual work. I think we spent 5-10 minutes, and I think that's how you can quickly solve a use case using GeoAI. So the problem was clear. We have to know the number of trees to submit the paperwork to get these carbon credits. I need to know how many trees I have, and in just 10 minutes, we can use GeoAI to do that. So yeah, I hope you liked that, and do drop any questions you have for later in the chat. Now I will pass word to my colleague Jacob.
Okay, yeah, great. Thank you. So yeah, I'm going to share my screen real quick. Okay, yeah, so as Enrique and Sergey mentioned, my name is Jacob. Nice to meet all of you virtually. Yeah, and I'm a data scientist at FlyPix AI, and I'm going to introduce another use case, that being wildfires. As Enrique already mentioned, one of the big differences, I'd say there's two major differences in this use case that make it different. I mean, of course, the fact that we're detecting something different, but with that we're going to be using a different model, so segmentation models. And we're going to have a number of files. So there's a bit of a workflow to handling large numbers of files in a project when we want to train across files and not just within rasters. So I'll walk you through that, but we can just hop right into it. So as I already mentioned, the goal is detecting wildfires, and to this end, we've trained a wildfire segmentation model. We trained it on data from an open data set that I was able to get from, or was provided by a group out of the Polytechnic University of Turin, I believe. It's compiled from Sentinel L2A imagery, particularly RGB bands, with the standard 10 by 10 meter resolution that we expect from that product. Yeah, and the use case for this particular model is, by and large, the use case that, or what we want to do with detecting affected areas of a number of natural disasters, so disaster relief, in order to determine perhaps people that's houses were burned down and need assistance, or damage estimation to determine the financial impact that the wildfires have had on a given region. So of course, having a segmentation of these affected areas can be extremely useful and integrated into further pipelines. But with that, let me, oops, that's the wrong slide. We can jump right back into the project. And here we're already in this little project view.
We stopped seeing your screen, by the way.
I probably just shared. Okay, now it should be visible again.
Yep, it's good.
Great. So yeah, we start right in this project view, and that we've seen that Enrique and Sergey both introduced. And we can just hop right into the Wildfires project. And in the Wildfires project, we see that there's all these files here, where before we only had one. Here, the major difference, of course, is that we have a number. And this comprises essentially all the files here comprise our data set that was uploaded here to the platform. And one of the first things that we want to do when we have a data set is we want to hop into the rasters and we want to validate that the data set is clean, that the annotations are good, and that we can expect that a model will be able to generalize for use cases or for areas that are outside and perhaps not represented in the data set in the first place. So we can open a raster, and this is one burned area. We can toggle it on and off and validate to some extent whether or not this looks accurate, correct it in regions perhaps if it didn't look accurate. For example, we can edit the annotation and move these points around and edit it like this. But okay, generally speaking, we then would do this for a number of files. We can open another file here. Again, do some validation. And this is kind of the workflow. You can even invite other members into your project so that you guys could all work on this together and get through all these files faster. So there's 174 images. It would take quite a bit of time to validate all that data alone. As a team, it would be faster. But yeah, then really one of the main tools that we need to grab to when it comes to training, as Enrique said, then one of the key products and value that we provide is being able to train a model in order to quickly and efficiently tackle use cases that we wouldn't necessarily have accessible to us without the platform. And in this context, this idea of workspaces really comes into play when we're talking about multi-file training. So how do you create a workspace? You can just open one of your rasters. You see this little scenes tab. You can open it up, and here we can press this plus, and now all the rasters in the project are available. So we can, I don't know exactly what this is going to be, but we can select this raster and add it. And then we have this raster here, and it's in our workspace. And we can continue to add scenes, and when we're ready, we can and want to save the workspace so that we get that little workspace thumbnail that we saw on the previous page. We can save it. We can add some context for ourselves in the future for team numbers. So we could name it my workspace and add a description like burned areas post fire. And we can save. And now it's saved in a workspace. And if we go back to our project page, we see it appears here. And you can even add thumbnails, and there's some nice little widgets. But really, let's jump into the one that I've prepared here. Now the question is we've done this validation. We think that we have a number of scenes, and we want to train a model now, not just on one file, but on multiple files. You see all these scenes here. We maybe see that we validated this data, and it looks good. And we want to train now. Now, just as before, this requires creating these training regions in all of these different scenes. We see that this last one actually doesn't have a training region, and so we can go ahead and create one. And it is exactly analog to the workflow that Kike showed. And so now we have this workspace with all these scenes, and things are looking good. Again, here, maybe a nice thing is we can add some context also to these scenes if we want to by changing the scene name. So for example, I named this one Croatia. This is, we can zoom out to get a better idea where we are. So this is Pamplona, just northwest, so we can Pamplona, southeast, enter, and now that will be in our workspace, and we'll now know where we are when we zoom to the raster, and other members will as well. But okay, we've created these regions, and we can create change, select train, and we can say my burn segmenter. Again, this is semantic segmentation and not object detection, right? The big difference that we're detecting, I think a good analogy is object detection would be detecting trees, while semantic segmentation would be detecting the forest, right? And here we're doing more of a forest detection. So again, we have the credits, and we can select all the files in our raster. We can press confirm. It adds up for all the training regions that we have. It gives us an estimate for the cost for our training, in this case, 1 credit, and we can start that training. And so that will start, and that will be training for, again, a little bit longer than the palm tree use case potentially, because we have more rasters, but on the order of 15 minutes. And because of that, we can actually jump over to inference after our model has been trained. Now, inference is, of course, it's the main use case once we have a model and we have trained it. Again, let's actually jump over here. We see this is the one I just started training. But here, burn detector, I named it a little bit differently. And just as before, we can see the metrics. We can see its performance. It has an IOU score of 75.1%. That essentially means an accuracy of 75.1%, which is pretty good. But anyways, back to the Wildfires project. Once we have that, we can perform inference. Maybe we have a use case, maybe a fire that occurred, and we want to now see where the burned or affected region is. So I actually took the LA Palisades fire as an example. This was in January and was in the news. So this is directly prior to the fire being started. I've actually already applied inference here, but generally, again, you would press apply, and it would start applying, and eventually you'd get your detections. Now, this is before the fire, and so we get no detections, which is, of course, one of a key indicator that our model is at least meeting minimal expectations. We can open another scene. This would then be after the fire, and I've already applied inference here, and we see now that this whole region has turned brown. So we have this region, and then just in the same area, this other region, we can turn on the detections, and it segmented it pretty well. So that shows, first of all, in a live use case, the usefulness of the model. We can look at some analytics now that we have them in 2 scenes in a workspace. We can change this to area. And we see in the first scene in January 1st that of this year that there was no burned areas in the AOI, in the area of interest that we were looking at. And then afterwards, we detected 40.6 square kilometers of burned region. Now, what's nice here is once you have this, you can, of course, then we want to export this maybe into further pipelines and use this in our own scripts or in QGIS or et cetera. And to this end, we can go to export as JSON, and we can export this shape, this polygon, and these detections and integrate this into the pipelines that really will help us tailor the work that we've done here to the use cases that we have that we bring to the table. Yeah, so we can go back and I'll just show you one more example. This was one of the reasons we want to perform inferences, not only in a real live use case scenario, but also to see how well our model has generalized beyond its scale, beyond the data set. And to this end, we were working in LA, and now I've taken a raster all the way from Australia in 2020. These were the Australian wildfires, and performed inference. And the reason I picked somewhere very far away is because generally that will mean that the natural features of the region will be different. And yeah, again, here we see that the model is performing quite well and segmenting this burned region. So this is one of the biggest fire in the 2020 Australia fires. So it's really quite cool that we trained this model on the platform on a data set, and now we're able to detect wildfires all across the world. And that's essentially it for that use case. I see that there's some questions in the chat. We will be getting back to those towards the end. So thanks for your patience. I'm going to then pass the mic back to Enrique, and he will introduce the final use case on urban planning.
All right, so we have one final use case I want to show you. We only have a little bit of time, so I'll go a little bit quickly, but hopefully it'll also give you another idea of what GeoAI can be used for. So I'll share again. You should be able to see my screen. So the last one I want to do is urban monitoring, because it's quite a common one. It is very common to want to detect and quantify the urban footprint, and especially monitor it over time. And well, GeoAI can help us do that very quickly. Now, who would want to do this? It's common in governments who want to do urban planning. They want to know where the city is growing. They want to verify whether people are constructing where they should be constructing. It's also used a lot by academia. So you might be doing climate change studies, human population studies, city prosperity index studies. There's a whole bunch of academia tracks that also require these kind of insights. And yeah, GeoAI can help you get these insights much quicker than by just manually segmenting the urban footprint of an area. So specifically, I chose a city in Bolivia, the city of Oruro, because I checked and it did have a lot of growth throughout the years. So I solved this use case in a matter of 5 minutes, and the procedure is the same. I load a Sentinel-2 image, in this case, into GeoAI, and I want to find this urban footprint, so the area that is built. Now, this is a low resolution, relatively speaking, image, so we don't have very fine-grained resolution of where the houses are, but it's enough to detect the urban footprint. So more or less we can tell that there are buildings here, but there are no buildings here. So to get a rough estimate of what the kilometers squared of the city is in terms of urban footprint, we can just use Sentinel-2. And as Sergey mentioned before, you can just fetch an image here from GeoAI. You can come to the data market, start searching, and select the area where you want to get it. Now, let's go back to this project, urban monitoring. And these are annotations that I created. So I quickly came here and I took the polygon tool and I started segmenting. Okay, so this appears to be houses. Maybe actually not. Maybe these appear to be houses. So I'm just going to quickly create a polygon here. Again, I didn't spend more than 5 minutes doing this, but yeah, actually I added the one to the wrong layer. Let me delete that. And then the procedure for training is the same. You create a region. You have to make sure that the area within the region is completely labeled. and I trained a model. And the output, if I disable my annotations, is this. So this is what the model detected. It did, again, for 5 or 10 minutes of annotations, which I didn't spend too much, I didn't put too much care into. I didn't make the polygons extremely precise. As you can see, I just roughly drew them around the urban area. The output of the model is actually quite good. Now I can, I also pulled images from 2020 and 2025. So this is 2016 here. This is 2020. And I applied the same model. And this is the urban footprint that it detected. And this is 2025. Here I also added some annotations for training to help improve the model a little bit, because this image was from October and these two were from June, and just the lighting conditions looked a little bit different. So to help the model a little bit, I also labeled a couple of polygons. But this is the output of the model. And yeah, again, this was these annotations were done in 10 minutes. The model trained, and then I just applied them. And we now have this analytics tool where I can take all these different scenes that I created, 2016, 2020, 2025. I can use the area as the metric, and I want to use the AI inferences as my source. And in 2016, the urban footprint was approximately 50 kilometers squared, which was 63 in 2020, and then it exploded to 107, below 107 kilometers squared in 2025. So, and yeah, again, in a matter of 10, 15 minutes, you're wondering what kind of growth the city of Oruro in Bolivia experimented. Thankfully, with GeoAI, we can do that very quickly. And this, you can apply this to 2022, you can apply it to 2018, you can apply it next year in 2026. So once that model is trained, it works out of the box for future data. So you no longer have to do any kind of example showing anymore. And it can also apply to other cities, so you can see how this could save you a lot of time to get those analytics that you need. So yeah, hopefully you like that. I think now we have a round of questions. So let's go for those.
Thank you, Enrique, and thank you, everyone. All right. So I have just a little slide. So yeah, we indeed have a Q&A session now. We don't have too much time, and we do have quite a lot of questions, which is great. So what we're going to do now is I'm going to let our friends from FlyPix AI go through some of the questions, give some very brief answers, and then we will take some time to compile a document with some more in-depth answers to some of these questions. So for now, I will just let you handle some of the questions that you think are most interesting to discuss here in the webinar. So feel free to take turns on that. Thank you.
Thanks. I will try to summarize a couple of questions that we received. So first one is it possible to upload own AI model to the platform? No, it's not ML platform to upload your artifacts, right? So you create your artifacts there. So for now, it's let's say a limited amount of models that are available on the platform. On the other hand, right, we take care to make sure that these are the most performant models according to the standard benchmarks that are typical for the industry. We also don't fully disclose the architecture of these models because first, it's a proprietary architecture. Second, we are evolving them on the constant basis, I would say. So it might be obsolete, some of the details. Is it possible to download the results? Yes, you can download the rasters. You can download the vector layer. Vector layer is the detections or segments that you receive. You can download them as a GeoJSON file and can convert it to any file that you need. There is another question or set of questions about the area estimation, right? So you get the area for every bounded box or polygon that you receive. You get also the cumulative area for all of the polygons or bounded boxes, so that you can understand the count, you can understand the area. There will be more parameters that we will be exposing in the future regarding all the detections that you get out of the analysis. Another set of questions regarding if the presentation will be available online. Yes, the video recording will be available. Please refer to the website of the platform. All right. Just checking some other questions. Yeah, with respect to the validation, very good question. What the results checked against the actual hand-counted number of trees? Typically, when you establish a model, right, so you provide your annotations, as Enrique showed, and then the system, while you are training the model, the system automatically splits your data set into different subsets, training and validation set, and on the validation set, it's estimate the performance of this model. So in principle, the numbers that you can see as a model performance, you should trust. It's hand counted in the sense that you did it on your own, right? So you obviously are free to establish your own benchmarks and to cross-validate it with maybe physical counting going to the forest and count the trees. But on the other hand, the image should be enough to get this ground truth. All right. Yeah, with respect to the credit system, Enrique and Jacob showed you that every training costs you some credits. So once you sign up and every month you stay on the platform, you receive a particular amount of credits. And these credits transform practically to the capacity of you to train the models and also to run inference. Practically how it transforms, we charge, or the system charges your credits based on the amount of megapixels that you use for training the model. And the ratio is approximately that you spend one credit for 20 megapixels of data that you train or inference on. Another question is how accurate we can detect different types of objects, right? So there was a question about humans and some other objects, houses, and so on. So it's a two-sided questions. The question first, it depends on the data that you are using for this. The most important, of course, besides different, let's say, physical issues, it's a resolution of your image. Typically, when you're working, for example, with Sentinel images, right, it's a 10-meter resolution. If you're talking about Sentinel-2, you are able to detect areas or segment typically areas, right? So you are not able to see or detect individual trees. If you are working with aerial images or drone imageries, and this is what's supported by the platform as well, you are able to detect anything practically depending on the resolution or the altitude or the camera that you have. So we have use cases where we were detecting bugs on leaves, right? So it was a drone footage and it was extremely high resolution imagery. And the second point here is that your accuracy or the performance of your model depends on the amount of the training labels that you create. So you need to invest a little bit into the annotation process. As Enrique was showing you, you can facilitate your life a lot by using our AI Copilot or AI that can really annotate you, hundreds of items within several minutes, and then your model will be pretty accurate. So I think I would stop here. We will try to compile also a written responses to some of the questions. Maybe we will expand a little bit, and I will keep the rest of the 5 minutes for the last points of the webinar. Thank you.
Thank you very much. I think before we go to wrap up, I'll let Barbara answer one of the questions about the
there was a
application to the...
general question on the DestinE platform and the upgrade access request. A user from the Geological Survey of Finland submitted a request, but still don't have access. I checked your upgrade request, it has been submitted correctly. We can view the request, but the process is managed by the European Commission. So unfortunately, we cannot provide an exact timeline for the review process. It's outside our area of action, but I can assure that it's going smoothly. I mean, it's been submitted correctly. Thank you.
Thank you very much, Barbara, and thank you everyone for your time in answering the questions. All right, so let's start wrapping up here. So just a few more things from our side. As we said previously, the recording as well as the slides will be accessible from the event page in the coming days once we upload them, once we host them. We also intend to add some more in-depth answers to them. So we'll compile a document. So those of you who have had their questions answered might be interested in learning a bit more about some of those things. And everything will be accessible from the very same event page that you used to sign up for the webinar. Secondly, please do not forget to fill out the expression of interest form, which is both an expression of interest form and a survey form for how this webinar was. I believe my colleague Claudia is now putting it in the chat, so definitely open that tab, save it, and fill it out as soon as you can. While we're on the topic of reminders, also please register for the next upcoming DestinE webinar. So this is for the DestinE initiative as a whole, not specifically for the DestinE platform, but it is for a use case of the DestinE platform, which is the GFTS, Global Fish Tracking System, which is happening next week, June 19th at 10 a.m. CST time. I think it's very interesting. They've developed quite a nice service for the platform, and I'm sure that it can be of interest to many of you. And that's it. So thank you all for coming here. Thank you all for your time, for your interest, and for your questions. It was a pleasure having you. And thank you, of course, to the Circo and FlyPix AI for organizing this webinar. Thank you all very, very much. And keep your eyes on DestinE for the next events and for the next opportunities. Thank you. Bye, everyone.
Thanks, everybody. Bye-bye.
Thank you.
Bye. Thank you, everyone.